Hello everyone, welcome to this episode of the Data Science Academy podcast. And in today's podcast, I'm going to answer the question, what is data science? So today I'm going to cover what is data science, what is the data science life cycle, and what skills do data scientists need? And is there a demand for people with data science skills? So let's dive in. Data science is a combination of various fields of study in mathematics, statistics, computer science, and information science. In data science, we use scientific methods and processes, algorithms, and computer systems to extract information from structured and unstructured data. We then use this knowledge gained from this data to drive business decisions, solve complex problems in business and in life, and build machines that mimic human intelligence, aka AI. Machines that mimic human intelligence, that's what we call artificial intelligence, AI. These machines we build that mimic human intelligence can see and recognize the things human beings see and recognize with our eyes. So when we look at something like a cat, human beings can know and can tell that is a cat. But when you tell a computer, like a machine, when you show a computer that's a machine the picture of a cat, it doesn't have a way of knowing that that picture is a picture of a cat because it doesn't have eyes, and so it can't process information like our brains can process the information of letting us know that it is a cat. So we have to train machines, we have to build machines and train them to be able to recognize the picture of a cat, so that when a camera system, when a computer machine sees a cat, it knows it's a cat. So yeah. And these machines that we build can learn new skills, just like a human being, do the jobs human beings used to do. And in a lot of cases, these machines can outperform human beings in skills and knowledge. There are a lot of things that machines do better than human beings. That's a fact. For data scientists to be really effective, they need to have a good background in statistics, discrete mathematics, computer programming, have a good understanding of algorithms, have good communication skills, and it's also helpful to have domain knowledge for the industry you are working in. For example, if you are working in the pharmaceutical industry, it's a good idea to have some background in biology or chemistry. If you're working in the finance industry, it's good to have some kind of finance background. So it's good to have domain knowledge for the industry you are involved in. Having domain knowledge in the industry you're involved in is not a requirement, it's just an added bonus. According to an article by UC Berkeley, there are 5 stages to the data science process. Stage 1 is capturing the data. And in this stage, you acquire the data, you receive data entry through customer input, you receive signal receptions, and you extract data from like websites and other places. That is capturing the data. There are different ways that data scientists capture data. Stage 2 of the data science process is maintaining the data. Under data maintenance, you have data warehousing, data cleansing, data staging, data processing, and data architecture. That's kind of the things that is involved in maintaining the data. And in stage 3, you have processing the data. Processing the data involves data mining, clustering and classification, data modeling, data summarization, and other things. So there are different things you can do to process your data. And stage 4 is analyzing the data. Analyzing the data mostly consists of exploring and confirming the data, predictive analysis, regression, text mining, qualitative analysis, and anything else you feel is necessary to analyze your data. And stage 5 of the data science life cycle is communicating the knowledge gained from the data science process. Communicating your data often comes in the form of data reporting, data visualization, business intelligence, and most importantly, making business decisions based on the data you are working with. Now that we've discussed what data science is and the process of doing data science work, let's explore some of the tools data scientists use to do their work. Let's look at programming languages that data scientists use. One of the programming languages that data scientists use is R. R is a computer programming language that is used for statistical and data analysis. It's mostly used in academia, it's also used in industry, but it's mostly used for data analysis. It's a specialized language for analyzing data. The next programming language we are going to look at is Python. While R is used mostly for statistics and data analysis, Python is like jack of all trades programming language. Think of R as a specialist specializing in data analysis, while Python is like the generalist that can do it all, from building websites to data science to building robots. The next tool we are going to look at in the data science toolbox is Apache Hadoop. Apache Hadoop is a collection of open source software utilities that uses a network of many computers to solve data and computation problems using the MapReduce programming model. Speaking of MapReduce, what is it? MapReduce is a programming model that is used in processing and generating massive data sets in parallel by first filtering and sorting the data and then using the reduce method, which performs a summary operation. So the key thing about the MapReduce programming model is massive data sets in parallel. Before Hadoop and MapReduce, you have a large data center and you'll be running a data science job, and that data science job using up all the computers in the data center. But with Hadoop and MapReduce, you can run multiple massive data sets in parallel of each other. You could assign different computers to run different data sets. And then the next tool we will look at is Apache Spark. Apache Spark is an open source computing framework used for programming clusters of data. And this next tool in the data science toolbox is fundamental, is very important. It's not just used in data science, but it's also used in web development and mobile development. It's used all across computer science, and it is SQL. SQL is a programming language used to store and manipulate data stored in a relational database. So SQL is like a programming language that we use to store information in a relational database. Whenever you hear relational database, think of Excel sheets. In a programming language used to store and manipulate data in a relational database, and you can, once your data is in a relational database, you can manage that data using SQL. And also, you also have something that's called NoSQL. So SQL itself has many different flavors, and each flavor of SQL has its own pros and cons. And the different flavors of SQL and why there are different flavors is a topic and a discussion for a different time. But for now, we'll also look at NoSQL. NoSQL is used to store and manipulate data that is stored in a non-relational database. So SQL is for data in a relational database, and NoSQL is for data in a non-relational database. That is basically data that's like, think of putting your data in Microsoft Word. You have a lot of data in Microsoft Word, and you have to work with that data and put it in Excel sheet. And Excel sheet is kind of like your relational database is kind of organized. And your Microsoft Word, the data you have all over your Microsoft Word is data, but it's not necessarily organized in a spreadsheet form. And then the next two we are going to look at in the data science toolbox is cloud computing. Cloud computing is massive data centers built by giant technology companies. These technology companies can then rent out their data centers and large computing powers to other companies and individuals over the internet. This way, average people like me and you and companies like Netflix can compute and run large data sets without having to spend the money, time, and resources to build their own data centers. Using cloud computing is much more time effective and much cheaper than building traditional data centers, which are really expensive to build. And of course, the big players in cloud computing is like Amazon Web Services, Microsoft, Google. They have a lot. These companies are huge, and they can afford the human resources, the time, and the money resources to build large data centers. And then they can rent those large data centers out. Like if you have a startup company, instead of spending time and money and venture capitalist money to build your own data centers, you can just rent out what you need, from these cloud computing companies. So that's basically cloud computing. Giant companies renting out their data centers over the internet to other companies and individuals. And now let's look at some visualization software that data scientists use. Some visualization softwares they use include D3. D3 is a JavaScript library and it's used for data visualization. And of course, it uses HTML and CSS. And then we have Tableau. Tableau is also a software, it's an interactive software that you can use to visualize your data. And there are many things out there that we use for data visualization, but these two are just an example of a data visualization software, data visualization programming languages and software. Now let's look at notebooks that data scientists use. So traditionally, if you wanted to write your code, you could use something like Visual Studio Code. If you want to write your code offline, you can use something like Visual Studio Code, and then you execute it, and your command line will show up and show you, the result of your code. But there are other ways to also write your code and execute your code without having to use things like Visual Studio Code. That is where things like Jupyter Notebooks and Google Colabs come in. Jupyter Notebooks and Google Colabs both do the exact same thing. Well, they don't do the exact same thing, their functions are similar. They are a computational environment where you can write your code, put comments on your code, execute your code, and just put regular text and math formulas as part of your notebook. Think of it as a regular notebook for writing whatever you want to write, but you can also write and execute code on it. There are many other computational notebooks out there like Atom, but personally I like Google Colabs more than all other notebooks I've tried. And that's because I feel like it's the easiest and most straightforward to use. I tried Jupyter Notebook, and the first time I tried it, it didn't function properly. It had a bug and had to Google how to fix it and other stuff. Basically, the first time I used Jupyter Notebook, it didn't work properly, and I got mad. And Atom doesn't work properly for me, so I default to Google Colab. I like Google Colab and use it a lot. And then the next thing we have to talk about in the data scientist toolbox. It's GitHub/Git. GitHub/Git is a software that developers use to track the changes of their code. You can use it to create different versions of your code. So if you wanted to go back in time and look at a different version, you can look at that. And it's also help to keep track of your code. So if you're typing and your computer breaks down or freezes or shuts down, you won't lose the work you've been doing for the past 6 weeks. That would be terrible. So you just kind of keep track of different versions of your code, and as you're writing your code, you commit your code and you upload it on GitHub. So if your computer crashes or if you need to go back 5 weeks from now and you're in a different country, you're in a different state, but need to have access to that code, you can just go to GitHub and get access to your code. And with GitHub and Git, multiple people can work in a group and they can use it to keep track of each other's code, as well as pull and edit somebody else's code. It is essential in every software development cycle. Like GitHub and Git is essential in every software development life cycle. Your employer will expect you to know GitHub and Git. Like, just learn it. It's very, very important. So far, we have discussed what is data science, the life cycle of a data science project, what tools data scientists use. Now, what is more important than figuring out what a data scientist is finding out if there's a demand for people with data science skills. And the answer to that question is yes, yes, and yes. There is a market demand for people with data science skills. Let's take a quick look at the numbers. These numbers is going to be based on data provided by Forbes magazine and Glassdoor. According to Forbes magazine, by 2020, there will be a 28% increase in demand for data scientists. According to Glassdoor, there are 6,510 current job openings for data scientists, and the median average salary is $108,000. Data science has also been named the #1 best job in America every year since 2015, and we are in 2019 right now. So for the last 4 years, data science has ranked #1 job in America. Now that you know there's a demand for data science jobs, the question still remains, what type of jobs are available with a data science training? In the next episode, we will explore various types of data science jobs, what people in those data science jobs do, what skills you need for the different data science jobs. So the skills and toolbox that I provided today is just like a generalization, but depending on which role you are in, depending on which job you are fulfilling in data science career field, the skills you need might be a little bit different, and a lot of these skills overlap too. But we'll look at all of that next time. And of course, what type of salary to expect from different data science jobs. And that's basically it for today's content. I am actually looking for podcast and video ideas. So if you have any ideas for me, be sure to leave them in the comment section below. And of course, I read all the comments. And the articles from Forbes magazine and Glassdoor and UC Berkeley will be left in the description on YouTube and on podcast. The show notes will be on my website at evidencen.com/blog. If you're listening to this on podcast, be sure to check out the YouTube version and subscribe to my YouTube channel at youtube.com/evidencen, and also subscribe wherever you listen to your podcast. If you're watching this on YouTube, just give it a thumbs up and subscribe. And thank you for watching. Thank you for listening. And I will talk to you guys next time. You guys and girls next time. Bye.